Morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, From Chaos to Clarity, How Data Lakehouses Empower AI at Scale, brought to you by our friends at Fivetran. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to dig into one of the most critical enablers of scalable, production-ready AI, the modern data lakehouse. As enterprises push to operationalize AI across teams and products, they're hitting a familiar wall: fragmented data systems that can't keep up with the volume, variety, and velocity of real-world data. Lakehouse architecture addresses that challenge head-on by unifying the strengths of data lakes and data warehouses into a single streamlined platform. In this session, we'll explore how lakehouses support seamless data integration from raw ingest to real-time analytics, while maintaining the performance and reliability AI workloads demand. You'll walk away with practical insights on designing and optimizing lakehouse environments to fuel everything from large-scale model training to intelligent decision systems without sacrificing flexibility or governance. We're honored to hear from a distinguished panel of experts today: Lynn, Vice President, Product Management Databases at Fivetran; Sanchit Srivastava, Senior Manager, Data Analytics at General Mills; and Ashish Dibouliya, Managing Director, Data Architecture at Webster Bank. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features in the right sidebar. We'll be addressing your questions throughout the webinar, so be sure to upvote the questions you'd like the panel to address. If you're wondering where your organization stands compared to others on your AI journey, check out the poll questions in the right sidebar. And finally, to learn more about how to leverage data lakehouses in your AI journey, check out the call to action below throughout the webinar from our sponsor, Fivetran. Now, without further ado, I'd like to welcome our panelists. Welcome, gentlemen. Thanks for joining us today. So we'll kick things off with some introductions. Just if you could just briefly introduce yourself, tell us a little bit about what you do within your current organization and any relevant experience that you have with data lakehouses. Dan, we'll kick things off with you.
Thanks, Brian. And hey, folks, thanks for everybody to join in this webinar. It's a pretty exciting topic. My name is Dan Lynn. I'm the Vice President of Product. I've been here a little less than a year, but I've been in the data industry for about 25 years now. It's been a while. Going all the way back to the days of big data and Hadoop, and going through that whole journey as we, the word data lake started when you started putting stuff in HDFS, so you put it in S3 originally, and it was, people were talking about data swamps back then. And it's really evolved as folks have figured out how to apply like really good data warehousing patterns, apply like multi-tier data architectures in object storage primarily nowadays is where it's done, using modern formats like Apache Iceberg, Delta Lake, etc., to enable transactional warehouse-like behavior on top of data that's stored in like your own object storage. It's really unlocking a lot of value for customers. It was fun kind of in my previous lives at different companies, watching how folks have evolved that and evolved their own architectures to really reduce their costs for just managing data and also get interoperability from lots of different query engines. So it's a really fun time to be in the industry.
Excellent. Welcome, Dan. Ashish?
Sure. First of all, Brian, thank you so much for this wonderful opportunity. Good afternoon, everyone. My name is Ashish, and currently I serve as a Managing Director of Data Architecture. I bring a total of 20 years of experience, and most of my experience is prominently around the analytical space. And throughout my career, I have delivered numerous high-quality enterprise-grade solutions, and they're all around the data. My core focus have been in a couple of years. So that's drastically shifted, and I'm basically more in leveraging the data and AI to drive the innovations and business transformation and strategical decision making. It's what my focus is right now.
Great. Welcome, Ashish. And Sanchit?
Hey guys, and thanks, Brian. I'm super excited to be here. Hello, panel, and hey, audience. Right. So, just like everyone, right, around 18 years in data, right? Uh, I'm super excited where data is right now. Currently, I am a senior manager for data architecture and analytics in General Mills, focusing a lot on enabling AI on the data, enabling AI-driven solutions, agent architecture in General Mills. um, I think this is a golden phase. I've seen, just like Dan and Ashish mentioned, right? We've all seen the journey from relational to big data of the world to to the GCS storages where typical Parquet files were there, and now we are here, right? So golden era, and super excited to share and help in this panel. Yeah.
Great. Welcome, gentlemen. So I want to get to our first question to give folks in the audience a bit more context about what data lakehouses are, what are some of their advantages that they may offer. So as I'm sure you guys know, data lakehouses have evolved from two different concepts, data warehouses and data lakes, that have long been used separately. So if you could just give a synopsis of what are some of the key advantages that data lakehouses have, and specifically with an eye towards what we're seeing in the world of AI right now and what the needs are likely to be in the coming years. How do data lakehouses help position organizations for success in that realm? So we'll start with Sanchit on that one. If you could kick us off there.
Sure. Right. For me, the biggest thing is agility and quality everywhere, right? In case of data warehouses, the biggest challenge was speed to deliver, right? We are building it for now, and by the time warehouse was built, it was future, right? And the requirements would have changed. In case of lakes, the requirements were not very clear. We were just building it, right? And they were not very specific cases of how to consume this data. I think Lakehouse is a very, very decent architecture and compromises both of them, the best of both of them. When you talk about the lake side of the world, right, you have the right governance practices, right modeling practices, right compute assessments being done, and you're building it for the enterprise without any specific requirements in mind. You're building it, but you're building it with a lot of governance. But on the house side of the world is where, if your lake is strong, right, you are now catering to specific requirements of business. So not only you're addressing the requirements of today through house, you're building it for the future at your lake side with quality observability, quality best practices of a data architecture. I think that to me stands out, right? I think that was missing in both of the previous discussed architectures, and I feel that is a huge value add for the organization.
Great point. Ashish, what are your thoughts?
Oh, yeah, that's a very interesting question. And I have been into, like Sanchit also mentioned, right? So we have gone through the journey of, working in a typical warehouse and moving to the data lakes and now lake houses and so on and so forth. So now, obviously, lake house is the best of both worlds, right? So it, while addresses the typical data warehouses challenges, at the same time, it's a combination of data warehouse plus data lake. In general, making this combination make it ideal for an AI-driven enterprise by offering a unified platform that support both structured and unstructured data, and variety of data that is prominently used for any AI operations or any AI analytical process. Well, this eliminates the need of multiple system. Lakehouse is basically serving that one. This also reduces a drastic data movement because everything is sitting at one place, which, if in a nutshell, enhances the overall performance and consistency, which is what basically I also believe in the key artifact for any AI-driven enterprises, and it's what Sanchit also mentioned, right? With the support for the open format or scalable storage, and you name it, native integration with the machine learning framework. So lakehouses are designed to basically streamline the AI development lifecycle from data ingestion to preparation to model training and development and whatnot. So there are built-in governance and cost efficiency features, which is equally important for some of the financial organization, as a matter of fact. And with all that being said, real-time data processing capability, which is where warehouses lack a little bit. is addressed basically in the Lakehouse platforms. So all of these, in a nutshell, empowers the organization to drive faster and kind of more reliable insight at a scale using the platform, the data lakehouse platform. It's what I feel it's um, the main advantage, and how it is uh, being used right now.
Yeah, great points there, Ashish, regarding streamlining. Absolutely. Dan, your thoughts?
Yeah, I think Ashish and Sanchit covered it quite well. I think for as businesses adopt AI for more and more like let's call it ad hoc business intelligence type stuff, you have this kind of like pendulum between like federated queries, which is kind of one way of thinking about agentic workflows, just querying data where it lies, which has all the problems of federation of putting operational load on those operational systems. Now, only now you have a new API user, and that's coming in from agents that folks have developed, versus kind of the data movement space where you're trying to centralize that in a warehouse, a lakehouse, and making the scalable data available to agentic workflows, to AI models in order to train, to operate it in production. I think the industry kind of goes back and forth, but there is a pitfall in just pointing your AI at your operational systems, because you introduce a lot of scalability issues. And so a lot of the learnings that I think the data industry has picked up in the last 10, 15 years or so around decoupling compute and storage, we get to now leverage that to accelerate AI. I think that's a really exciting thing. And so like a couple things had to happen in order to make that work for Lakehouses. You had to have cloud data warehouses figure out how to decouple storage from compute properly. You had to have object storage get to a level of scalability, performance, reliability that you can trust it with your mission critical data. Now you have AI, things like model context protocol, things like like RAG style approaches, vector databases. They end up being a last layer of transformation often on data products that makes that kind of gold level trusted data now available to agentic workflows. So I think it's a really great like icing on the cake of the overall data journey. The Lakehouses in particular accelerate because you put the actual data itself in your object storage. You put it in your S3, your Google Cloud Storage, your ADLS, your OneLink, and then you can bring different query engines to that data, governed in most cases. Apply your governance on that, get the best tool for the job, instead of having to kind of standardize on one query engine. And so I think it's a really cool time.
Yeah, excellent points all around. I want to jump on a point that Ashish made on the last question about different types of data, structured, unstructured. So that's obviously increasingly a key question as AI becomes more and more advanced, as large language models enable us to do things with unstructured or semi-structured data that maybe were much less feasible in the past. What are some of those challenges in integrating structured, semi-structured, and unstructured data, and how do data lakehouses assist with that? And what kinds of things do you need to think through when you are deploying a data lakehouse architecture that is going to be incorporating all those different types of structured, semi-structured, and unstructured data? So Ashish, why don't you start us on that one?
Yeah, that's a great question again, and this is something that we face on the day-to-day basis. While as we all know and agree that uh, the data lakehouse platform is designed to basically store the structured and unstructured data in its original shape and form with some addition to it, right? But there are challenges to bring that on board, right? So organizations generally face several challenges when they integrate structured data or semi-structured data and maybe unstructured data as well, as a matter of fact, right, with within the lakehouse architecture itself, including the complexity of first of all the ingestion, right, and normalizing the diverse data formats. So what happens is, you get data from diverse platforms, but to normalize and it making usable, it's the biggest challenge. And then obviously the second part is ensuring the consistency around the metadata and the governance across all type of data that we are bringing in. And as we integrate a warehouse with a lake house, or a data lake with a warehouse, the maintenance become another issue. Say we solve one problem, then there is another in hand. So maintenance of this data that is continuously increasing, the performance and the maintenance would come as another challenge. Then what happens is when we talk about the semi-structured or unstructured data, then generally the managing the schema evaluation, enabling the secure access control is another problem that basically I faced in one of my project, and supporting obviously advanced analytics, because there is continuous data change, there is continuous schema evaluation, right? So there is the need of advanced analytical always imposes another challenge, right? So while data ingestion, data preparation, and then data consumption, all three things comes at the same time. Why? Because this is slightly different than a relational database. And then obviously, supporting for advanced analytics, as I mentioned, across the heterogeneous data source become very, very challenging. So overcoming all of these challenges requires a very robust data integration, and call it data ingestion tool, then a unified governance framework, and then performing the maybe the optimized storage format to ensure seamless and efficient data ecosystem would play a crucial role to make this a useful ecosystem. So some of those is what I could think at the top of right now. So, yep.
Excellent tips. Dan, what are your thoughts?
Yeah, there's with especially with object storage, right? It's easy to talk about, you're using S3 or ADLS or something, and when you start thinking about that, like file formats, especially for semi-structured, becomes something you should think very carefully about. And I've run into customers who get burned, like Fivetran customers who get burned using things like CSV when there's wildly better options most of the time. Right. And, everybody defaults to CSV, it's fairly rampant, especially in financial services, right? Ashish, of like lots of data vendors producing data products that are then consumed from SFTP. And, you've got all the quality levels and that you have to deal with there. But as like organizations start to think about like, oh, I want to leverage object storage and really like rethink a data lake. I want to put unstructured data in there, which is like true unstructured data, but then things that look like tables, it's really worth your time to think about investing in a format like Apache Iceberg or Delta Lake or something like that brings schema, and not only schema, but it brings a file format that allows query engines to make very smart decisions about pruning files out. So you don't have to do what Hadoop did back in the day, where it had to scan petabytes to query megabytes. Right. And so you're able to do much smarter query planning if you think about those file formats appropriately. The good news, there's lots of engines that do that thinking for you. You just have to choose kind of like, how do you want to write the data? Things like Iceberg is a very prominent one. There's other challenges. I think it's a relatively new area where folks are trying to decide like, how do I want to govern access to my data? Like, where's my like catalog of reference or my system of record for where I'm going to be enforcing table level permissions, column level permissions, things like that. And you want to make sure that you think that through as you bring these different query engines to the picture. Governance, and more specifically fine-grained governance, is something I think you want to think through. There's really good advances in those formats nowadays that are helping that out, but some organizations may be like, oh, well, it's an object storage, I can just use IAM at the object storage level, and that usually only gets you down to the file to see like who can access which file. If you want to get a little lower, you want to do row level filtering, things like that, you're going to want to use a catalog layered in front of that to help govern the access by different query engines, right? So that's something like the Apache Iceberg standard has the Iceberg REST catalog, right? There's an implementation of that called Polaris. There's a lot of commercial offerings around that as well. But really thinking about the data you're putting in your lakehouse as tables, one that's structured is a great way to start. And you can take a lot of the lessons that you would otherwise use in a regular data warehouse and apply it to a lakehouse as well.
Yeah, great points. Sanchit?
Yeah, only thing to add here is, right, I mean, just the capability of co-locating both structured and unstructured and semi-structured data together at Lakehouse, it's a huge compliment. It's a huge acceleration for AI. And I mean, yes, we developers can do things which we do, right? We are essentially more requirement-driven community, but AI is a scavenger, right? I mean, it can find things which we are not looking for, and co-locating these, all kind of data in a lakehouse architecture is an extremely powerful tool which data teams have now. And with the right governance, as both Dan and Ashish mentioned, right? I think more is to come, in my opinion.
Yeah, I want to just double click on that idea of governance. Certainly critical to the conversations around AI and to data lakehouses. So Dan and Ashish, you guys both touched on that a bit, but anything to add there, I guess, on how lakehouses help maintain this robust governance, lineage trackage, compliance? Like, what does that look like in a data lakehouse world that may be different and better, hopefully, than some other environments that you might have? Sanchit, do you want to kick that one off?
I mean, this goes back to me for Lakehouse is the best of both worlds, right? I mean, where Data Lakes was a wild, wild west, if I can use that word, and Warehouse is let's get everything done right, is that kind of word. Lakehouse is a very decent compromise. The lake side, where you are implementing the right practices, which typically, a minuscule size of warehouse practices, which you're putting in on the lake side, enables you to track your lineage very well. The IAM practices which you put on your lake side, right, ensures that governance has a role to play. You're restricting the data, you are respecting the data privacy the way it should be. And when you get to the house side, right, you're talking of more practices coming into picture in a much larger way. You have restrictions, you have RLS, and Dan alluded to that, right? RLS, CLS in place, right? You're tracking who is using it, you're auditing it through all kind of peripheral tools which lakehouse architecture provides. So I think, as I said before, right, the best of the best, right, of both the worlds takes us naturally in a lakehouse architecture in terms of lineage driven, because you're architecting your lake side very well. You have lineage enabled there. And then obviously the house side gives you the lineage very well because you have analytics consumption happening at that side of the world. Governance practices, since both are certified data in a way, governance practices has a role to play. So you're ensuring your data is reliable to an extent depending on the end users. And both places you can put IAM controls, right, to respect data privacy and data security aspect. I think this is this is how we can do it.
Yeah, great points. Dan?
Yeah, one thing I think is cool on the security layer is that differs from, I think, the traditional ways of managing, especially like cloud data warehouses, is like it's your organization's cloud accounts that are managing that storage. So it's the IAM policy that your operations team is using for all the rest of your cloud footprint, right? And the same tools and technologies they're using for that, they're able to apply to, in this case, buckets and object storage. And then you get a layer of like Iceberg catalog on top, which adds finer grained permissions. And so, but there's things that like were often hidden or obscured behind a cloud provider before, like network access controls and things like that. That you now have finer grain, and in this case, multiple layers of security to protect data, which is, I think, pretty exciting. On the lineage side, it's also helpful because you have one consistent transaction record for, let's say, a single table, even if multiple different query engines are writing to that. So it allows you to use the right tool for the job, specifically for like data preparation, data stewardship, as you go from raw to like intermediate to like MART level data, or bronze, silver, gold, however you want to think about that. Each of those transformation steps, usually reads some data and writes some data, and often produces a new table, or it updates a table in place. And you get transactional auditing, even if one of the engines of that is maybe Apache Spark or Trino or something like that, and another engine that's querying it later is a cloud data warehouse or something like that. You can use both of those with one consistent transaction log and get that like really great lineage across the database that you otherwise would be locked more into one particular engine, even if it's not the best tool for the job. And we've done a lot of research where we see folks using like cloud data warehouse engines, like to do like relatively mundane data processing. So you bought this really great sports car and you're like using it, to like mow your lawn practically. And so being able to pick and choose the right engine for the job has huge cost benefits as well.
Great points. Ashish?
Yeah, many important points are covered by Sanchit, and just to add a little bit on it, right? So when I look at the governance, there are four. While the governance is a huge topic in itself, but there are four main or most important aspect when we talk about governance and what is the offering when it comes to Lakehouse. So one is the data quality. Now, data quality again, can expand broadly. Um, Data management, fine-grained access control, then built-in support for data lineage and auditability. These are the four most important things which enables a good governance in the data quality. And Lakehouse has the offering for all of what 4 or 5 things that I mentioned. Again, governance is a huge topic, but let's focus on these four for now. Now, so Lakehouse enable organization to track the origination of the data, transformation, and usage of the data across all the AI lifecycle. Like then you mentioned, we have the bronze, silver, and gold layer that can very well gel up with the whole concept. They also, I mean, the with all of this enablement, the Lakehouse also ensures a transparent and trustworthy model output, which features like role-based access control, then schema enforcement, or compatibility with some of the very prominent governance framework, which are used across the organization, something like GDPR or HIPAA. So in a nutshell, Lakehouse help maintaining the regulatory compliance with while delivering a very clean, trustworthy data for specifically for the AI-driven decision making. So as far as those 4 points are covered, they are very well covered, and in the Lakehouse platform, and that can enable the organization to have a very controlled governance.
Yeah, great points. Governance, of course, very, very critical as AI continues to evolve and do things with our data that maybe we didn't foresee a few years ago being able to do with our data. So another key point as we talk about productionalizing AI within enterprises is the idea of ROI and ensuring that as you leverage data in new and exciting ways, that we're doing so in a way that's also cost effective. And so how do you manage that cost effectiveness of storage and compute when you're dealing with very large scale AI workloads that can very quickly send your costs through the roof? So what are some keys to managing that you guys have seen be successful, and what do you think are important to keep in mind in the coming years as this becomes even more important? Dan, why don't you start with that one?
Yeah, I think that's one of the things that's most exciting about this, because not only does it make it easier to govern, like we mentioned before, by reducing copies of data are expensive. And so if you can put like a single source of truth for a given table or subject area of data in one place, and then different departments can all access that in a governed manner, you've eliminated a lot of copying that you might have otherwise had to do because of like the architecture of your data processing systems. And so as you get this more open, interoperable ecosystem, you're eliminating copies, which is a great way to reduce your cost. I think another way is because you're able to set your own storage policies within your object storage. You're benefiting from negotiated pricing with your cloud provider. You're able to use intelligent object storage tiering in those areas to expire or to fade out old records, but be able to bring them back from cold storage as necessary. Lots of like storage optimization things that can be done right in alignment with like your organization's storage management policies. On the compute side, you're able to bring the right tool for the job, and I think that I was speaking to that a little bit earlier, so I won't rehash that necessarily. We did do some like analysis. Like there's a lot of cloud data warehouse spend these days is spent on merging the incoming records from whatever your incoming system is with the existing records you have in your bronze layer, and you're having to do effectively a merge operation And that's a pretty compute intensive process, depending on how that data is structured. And being able to use the right compute for that, scale that appropriately and independently saves a bunch of compute that you can then use for other use cases within your data estate. So ingesting, I think the iceberg layer is really helpful there. I'll leave it at that, but it's like there's a storage benefit to this and a compute flexibility benefit as well that have pretty big ROI implications.
Yeah, absolutely. Ashish?
Yeah, this is again a very good question, and that is something that always comes in consideration while choosing a right data warehousing platform, or for that matter, the Lakehouse platform, right? Now, what happens is the good part with the Lakehouse platform is that the storage and the compute is separate, which allows basically the scaling of the component independently, which means say if I need a workload demand, I can scale the compute. There is a storage demand, I can basically independently scale the storage. There is no connection. Using some of very prominent file format like columnar or something like Delta or Parquet or maybe Iceberg also enforces the optimization of storage. While they can scale independently, but how do we optimize? It's another challenge, right? And that's where some of this prominent file format, it's what we have to utilize. And again, it's a use case driven approach, right? Like Sanchit mentioned during during the conversation that we work on a use case. We are a use case driven industry, which means we develop a product, design a product based on what is the use, or what is the use and who is asking for it. So utilizing the right file format would play a very crucial role here. Additionally, maybe implementing some of the traditional tactics, as in auto scale computer resource, which is again an offering of the Lakehouse platform. Then maybe the lifecycle management, which is basically archiving the cold storage, and reducing the data duplicacy, not storing multiple version of the data. And then maybe intelligent caching for further minimizing the unnecessary resource utilization. Then having a very effective cost monitoring and optimization tool that sits as a layer on the top of Lakehouse platform. There are many offerings available in the market beside what Lakehouse platform offers themselves, right? So these tools integrates into the modern Lakehouse platform and also help tracking the overall usage pattern, be it the storage or the compute. And then they also enable the recommendation pattern, right? So what is going wrong, and how can we use that? Then in some cases, you can build your own framework to track these practices. So that's where basically I think I would suggest leveraging right file format. Storage and the compute can scale separately, and then a proper lifecycle management or intelligent caching. And some of these things are going to play a crucial role in managing the cost, because the moment we bring in the data into the Lakehouse platform, which is basically a free form data, right? So we are bringing in as we want, because there is a AI sitting on the top of it, and that's our need of the hour. Managing that data efficiently, and how the compute power sits on the top of it to get the best out of it, plays a crucial role there. And all of those methods can probably help.
Yeah, great points. Sanchit?
I think both Dan and Ashish have spoken a lot, right? And my response is a mix of same. Be smart. You have a lot of levers, right? As compared to other architectures you have. Your store, most of the cost is at compute. So be smart. What do you want to compute and how do you want to compute? What kind of critical use cases you are tackling with? And you have options to have interactive, non-interactive, always live clusters, what kind of GPUs, TPUs you want to use. But if those are low priority, low critical use cases, you are very well addressed with low compute environment and keep the data in your storage locations. And both Dan and Ashish mentioned, right, ton of features are available to manage your storage cost, right? Life cycle, hot, cold, archival strategies, ton of features are there, right? So a lot of options because compute and storage is different. Be smart for your use cases is what I would recommend.
Yeah, great points. So I'll open up this next one to the floor, anyone who wants to jump in. So we've talked a lot about the potential benefits of data lakehouse architectures, especially as as AI continues to develop. But just wondering if you guys have any real world examples, either from your own organizations or that you've seen, that are good examples of how data lakehouses actually move the needle with respect to AI driven insights.
I can go ahead and jump in. Maybe I got a couple. I mean, Fivetran, obviously, we're sponsoring this. We're a vendor in the space. What we do, for those that maybe not be familiar, Fivetran delivers data into analytics environments primarily, right? So we're a very reliable connector between all the different places you might have data and all the places you might want to analyze that. We've got, I think now over 800 different managed connectors to all sorts of different SaaS applications, databases, you name it. And we reliably move that data into cloud data warehouses, SQL databases, and also lakehouses. We have a managed data lake service. One of the areas I think some of the customers that have used that managed data lake service, like they get a lot of value in achieving that lakehouse vision, right? Like we've got a few referenceable customers. Like there's a pretty good case study on our website from a marketing agency called Tenuity that was able to get their new customer onboarding time improved by 120x, not 120%, 120x. They got setup time for new data ingestion pipelines down from 2 to 4 weeks down to under an hour into an S3 data lakehouse. So being able to significantly accelerate that time to value for onboarding new customers, new use cases, things like that. And then being able to govern that in a centrally managed way, like we've just been talking about, lets them control the cost as their customers add data onto the platform, and you'd be able to leverage that. We also have some use cases, I think, in financial services. Like the one that I think resonates really strongly with this interoperability play is a lot of customers are centralizing data platforms where previously you had lines of business, each running their own data ingestion stacks. They're doing their data quality stacks. Governance was really expensive. And when you can centralize the governance without putting up a walled garden where nobody can help, and you've now created hidden all data operations behind the one data team, and if you want anything done, you got to take a ticket, and the queues line up forever. Being able to have everything governed in one place, but automatically governed, so that you've enabled self-service for all these different lines of business on a standardized platform is the vision that so many companies are executing on, and they typically have 3 to 5 year missions where they're trying to do that. And for at least for Fivetran's customers, a lakehouse architecture like Fivetran's managed data lake service is right in the middle of that, because they get that self-service new pipeline addition. You get the governance inside of your own object storage. You get the reliability and high performance querying of Apache Iceberg, Delta Lake, and then integration with different query engines and downstream catalogs. And so there's that kind of data centralization use case as well. And then there's that time to value of additional, kind of bringing new things on just off the top of my head.
Yeah, great points. Any other thoughts, sir?
I mean, without diluting too much of information here, right? I mean, we did, have a real-time campaign management tool built in one of my previous company, right? Where we were leveraging real-time ingestion, right? And on lakehouse environment, and AI coming in, finding the relationship between the past purchase history and the recent web scraping history, and recommending potential campaigns and then sending them out, on a real-time basis. So worked out really well for us. So, yeah.
Just to add here, right? So basically, while I don't probably want to take a name of any such real life example, but I know there are financial institutes. They hugely got benefited using the Lakehouse platform by their overall fraud detection mechanism got improved. The personalized customer experience, or call it ensuring the overall compliance and finance regulation, that has got to the next level with the Lakehouse. It's what I basically learned when I was doing some research and I was doing some study. So I think it's playing a very crucial role in those sensitive areas, and organizations are taking benefit out of it.
Yeah, excellent points all around. So for organizations that are thinking about migrating to a lakehouse architecture, maybe they don't have one already, or they only have one with respect to certain aspects of their business and not everywhere. What are some of the challenges, potential pitfalls in migrating to a lakehouse model, and how can organizations deal with those? Why don't we start with you, Sanchit?
I think migration from a warehouse to lakehouse. I mean, I probably will sound a bit philosophical here, but I think the mind shift is a big thing you need to watch out for. Change management is a big thing you need to watch out for. In terms of technology, right? You might want to assess your current warehouse readiness to do this migration, right? Just like a lake house, right? You also have multiple data layers in a warehouse. You have a raw layer, you have a transient, and then you have your final warehouse layer, right? You might want to see that, are your data elements ready to be stored in an object layer or not, right? They are built in that way or not. One of the key differences between a lake house architecture and warehouse architecture is the size limitations, right? The chunking mechanism to optimize queries in a lakehouse architecture versus you don't really care about warehouse because you have a huge cluster behind the scene, right? Watch out for those things, right? To make that happen. If you are just lifting the data from your warehouse into a lakehouse architecture, watch out for your large tables, is what I would recommend. I think those are the points for a forklift like scenario comes to my mind. Happy to hear more from Dan and Ashish.
Yeah, Dan, your thoughts?
Yeah, we're still, I think, coming up the maturity curve as an industry a little bit, but there's been a lot of progress in the last few years. I mean, Iceberg, for example, is let me do the math here, 6-7-year-old format now. I think Netflix open sourced it back in 2018. And so there's been like a lot of community adoption around that, right? And a lot of like early teeth cutting problems solved by the ecosystem and the community. And that's really like solved a lot of the open kind of interoperability issues. It's not that there aren't challenges. Still, like as Sanchit mentioned, there is a little bit. You've taken something that like the warehouse was fully managing under the covers, and you've kind of like lifted the hood a little bit, which has enormous benefits, but it also has a few trade-offs. I think it was maybe Ashish earlier mentioned table maintenance as a function, which is, Iceberg and Delta Lake are they both support time travel on queries, for example, and so you have snapshots that go back in time. And if you don't maintain your tables, those snapshots just pile up and fill up your storage, and you don't achieve those cost benefits, for example. And so somebody's got to do that snapshot management. The community has ideas around that. So you do need to manage those tables in your lakehouse. It's a nice opportunity for me to pitch our managed data lake service where we do that sort of stuff, right? So we, when Fivetran writes data into your S3, we write both Iceberg and Delta tables at the same exact time, and you get those same transactions at the same level, and then we manage the snapshots under the cover. So we are dynamically compacting that data to keep it optimized for queries as we write it, and we're also maintaining a snapshot expiration policy to prevent your storage from growing out of control. So it's something that if you just kind of like jump into it without really thinking about it, you get yourself into trouble. There's a few other like design choices about how your query engines write data. So when you're doing transformations, there's two different flavors of writing data depending upon the speed. There's copy on write, there's merge on read, and there's some trade-offs that you want to make at a table level. So there's just a little bit of education to get used to I think the new way of thinking about this and helping to figure out which engine is appropriate for which kind of data. You get a rich palette of colors, but now you have to do a little choosing, which for an organization can, I think to Sanchit's point, mean that there's some change management, some education and enablement to really get the most out of the flexibility.
Yeah, great points. Ashish?
Yeah, I think then, Sanchit, you covered very important points. Just to add into this, right, basically, I feel the most important or the biggest challenge is one, training, and two, adoption. As long as that happens, it is very easy to adopt Lakehouse. Now, so what we do, right, generally we have a warehouse platform we are migrating from warehouse to lakehouse, there is a compatibility. It can be migrated. Architecture is, re-architecting the whole warehouse. It's not a big deal. That is again a use case driven approach. How organization want? What is the actual use case? What is the lakehouse being built for? Can be done easily. Uh, but can that also enable the existing reporting or the insight that we have on the warehouse platform? Warehouse platform basically has a very distinct offering, that is regulatory reporting, and they do best in that, right? Compared to the lakehouse platform, they are designed for advanced analytics, AI use cases. So when we migrate from a warehouse to a lakehouse, it is important that some of these existing reports or data insight continues. At the same time, we adopt it. The organization wide adoption is another big challenge that we generally face. There is always some sort of resistance because people and everybody is very well acquainted or comfortable with the way things are working. Moving from one place to another place and shifting them a little bit probably comes, I mean, again, to Sanchit's points, I might sound some philosophical here, but that's the truth. That happens all the time, right? So it's shaking up a little bit, may bringing people out of their comfort zone is the biggest challenge. And obviously after that, making sure that the lakehouse has the equal or very consistent prominent offering of the data warehouse platform, some of the regulatory reports and all that should continue. So those are the challenges that generally organization face when they migrate.
One thing I'd add there, Ashish, which I'm glad you
Yeah.
brought that up. I think the ecosystems like really recognize that tool preference or the affinity for like my specific flavor of SQL or the way I like running that my engine. Like the investments that all the different like cloud warehouses, for example, have been making over the last year, especially, and continuing to make this year, in being able to let their users live in their data warehouse, writing SQL, and having that SQL execute against data in the lakehouse. And in many cases, the user is not even aware of what kind of table it is, right? You're querying a native data warehouse table or you're querying an iceberg table. And in many cases, the UX has gotten to the point where you can't tell the difference as a querying user, both from a performance perspective and from a SQL perspective. You're not writing a new flavor of SQL, right? You're not having to like learn all these different ways of querying. You can kind of preserve that, and you've just swapped out the underlying storage layer for that table, and that I think provides a really smooth like on ramp for folks to like make that change.
That's a very good point.
If I can just add to Ashish, I think Ashish alluded to that, right? We spoke about change management, we spoke about architecture, we spoke about look and feel. I think team readiness is an important component, and Ashish kind of brought it up, right? Because the way a developer thinks in a cloud warehouse environment versus the way a developer has to think in a lakehouse environment is slightly different. I mean, the end goal is the same, but the surrounding challenges are different, right? So team trainings are going to be a huge amplifier if we're making this transition. I just wanted to call that out too.
Yeah, those are great points. And we've got a good question in the chat that I wanted to pop up here as well. This is a question from Bonnie. I'm in a global tax practice where data cannot be moved and needs territory-specific access control. Delta Share is a game changer for us in implementing a federated data model. I'm struggling to sell the idea to territories due to RNQ. Any advice? So it sounds like we've got some data silo issues here, some governance issues. So I guess who wants to chime in on that? Any or all of you to give your thoughts to Bonnie?
I can try, right? Maybe Ashish just looks like your territory. So
You go first, Sanchit.
Yeah. I mean, under the hood, right? All these are storage, Bunny, and storage has a location defined. We call it as regions, or we call it as data center places, whatever you want to call it. With federated data query enablement, data does not move, right? You can make sure that the restricted data you're talking about stays within that region, stays within that data center. Those features exist in Delta Lake. You can sell it to your leaders saying that, hey, data is still safe. It's not moving to any other data plane. There is no movement of data. It is the query engine which is going to that place and running the query at that place itself and getting the data out, right? The output is presented to you at a different place, but there is just no data movement happening. It's locked down the way we wanted to lock down in your current setup. That's probably a way to explain. I'm sure Ashish has seen this many, many more times. Yeah.
No, you actually did it right. You did mention it rightly. It's exactly what I was trying to say. What happens is that in olden days, data used to move. Now the compute moves. You keep the data where it is, and instead now the compute is which is going to move. So you're not moving data. It's just the compute. So bring in a concept something like data fabric or data mesh. With while don't restrict yourself with technology. Data lakehouse, think of data lakehouse as a framework, and then try to implement or gel this with a data fabric or data mesh layer, and that's the way to go. Yeah.
Yeah, great explanation. Another question we have in the chat from Eric. How do you approach optimizing data freshness and data latency in a lakehouse architecture, especially when balancing batch ingestion with real-time or near real-time use cases? Weigh in on that.
It's very close.
I can hop in, but seems like you got an idea too. That is, I would say, a problem that there's some laws of physics that no technology yet is going to just silver bullet solve. Generally, the faster and low latency writing you want to do, you're generally going to pay for that on the query side, right? And kind of vice versa. Like there's especially with columnar stores, like Parquet format, which both Delta Lake and Apache Iceberg are Parquet under the covers, and Parquet is a columnar representation of data. And so if you have a high speed stream of row level events, right, at some point something's got to convert those rows into columns and save them in Parquet. And so that there's an inherent latency that writes those Parquet files. And so there's a trade-off there, which is the smaller your Parquet files, the more of those you have to scan downstream when it's time to go query. The nice thing about I think these modern data lake formats like Iceberg is you can write that kind of like high speed, smaller Parquet files, and you can go ahead and clean up and compact that data effectively as a branch of the table, and then rewrite that at the top of the head. And generally be able to do asynchronous compaction optimization of the Iceberg table to improve downstream query performance while generally preserving your low latency writability.
And I'll just add this, right? Whatever Dan mentioned, and I think the question was from Eric, right? Eric, you should look for Lambda architectures. That's what Dan is explaining. Using the lakehouse architecture, you can always do real-time transformations through serverless functions, but then you can run a process to compact them together in a seamless manner, right? They offer CURD opportunity, so you won't see when the compaction operates on the real data. So learn about Lambda architecture, and you will learn more.
Yeah, great points. We have time for, I think, one more question. So I see a bit of a different perspective here from Nicholas in the chat. My organization's data are currently in silos. What would be the first step? I'm listening to this webinar, and it looks like a data lakehouse is a very complex solution for something like digital marketing. So I guess for folks who maybe feel like, there are some low-hanging fruit types of problems like siloed data. I mean, maybe that's not so low-hanging fruit depending on the type of data in the organization, but that maybe feel like this is too complex. How complex would you guys say this really is to migrate to a data lakehouse? How much are organizations really committing themselves when they start this process? And what types of use cases, does every use case with siloed data kind of necessitate this, or is there some kind of a crawl, walk, run that organizations should be thinking about?
I'll say a little brief thing and then hand it over to Ashish or Sanchit. I think depending on the size of your organization and the rigidity of the silos, this may apply differently. But generally, you're wanting to pitch that vision of centralized governance, and you want to have that, like, get everybody aligned with the vision for where we want to go as an organization. And once you have that sorted out and people are like, yes, we want to do this. And then there's a question of how, and you either do that kind of one use case at a time, or you work your way more horizontally with different like business domains, which are maybe multi-use case. But I think with any sort of organizational transformation or digital transformation like this, you want to focus on early, like prove value early and get adoption early, before you end up with a 12-month or 18-month project plan that doesn't deliver any value until the last 3-4 months, right? Because it's very easy to lose faith along the way there.
Great points. Any thoughts there, Sanchit or Ashish?
No, I think I'll echo that, right? I mean, every organization have to think, and I could sound a bit right. So, I mean, are you an AI-driven organization? Or are you not? Will you be AI or will you be not, right? And if your answer is yes, we will be using AI, I think this is a great solve, right? Because as we just spoke, all three of us, right, co-locating, structured, semi-structured, unstructured, you have a lot of options to manage your compute cost, your storage cost. You have speed to delivery in your lake, but curated data set can be presented out with a different set of compute toolings, right? The options are very unlimited, and the positive uncertainty which AI is bringing in this technology world, I feel Lakehouse has those, spokes to address those, right? Versus other architectures seems to be much more rounded because they are much more proven and much more stable, which probably would need some folks, right, to support AI. So I think that's what I would say. Think longer, not immediate, is what I would recommend.
And just to add there, right, and this is something that we see on the day-to-day basis, right? So data silos is the biggest challenge. What is the first step, right? Is to identify a use case. You can't move the whole, all the data at one go at one centralized location. It's practically impossible, right? But we have to bring the data at one place for enabling maybe the AI use case or an advanced analytical use case. So what is the first step? Take a use case, bring data, what is needed to serve that use case, prove it, make that as a framework, and then start adopting that same way. So to what Dan mentioned and to what Sanchit mentioned, taking a use case, proving your value, or proving your point by demonstrating, giving proper demos would play a crucial role here. But data silos that we see on the day-to-day basis, and it's one of the biggest challenge that we all face. But the way to go about it is to basically take a use case, solve it, prove it, and then use that as a framework.
Excellent points. And with that, we will wrap up. We're at just about out of time. So I want to thank all of you for joining us today. Excellent panel, excellent insights from all of our panelists. If you missed any of this webinar and would like to rewatch anything, the recording will be available just a few minutes after the webinar concludes. If you refresh this page, we'll also send out the link to our YouTube channel tomorrow. And want to say a special thank you again, both to our panelists and to our partners at Fivetran for making this webinar possible. And we'll see you all again next time. Thank you.
See you guys. Bye.
Thanks.
Bye.